All right, we were looking at IPv6 tunneling. You might hate this one. We have a series of requirements and restrictions here, and a quick diagram showing our loopback addresses. Our goal is to have a full mesh topology so we get most efficient routing, and at the end of this, R1's loopback should be able to ping R2's loopback, vice versa, and R3 should be in that mix as well. So, first things first, we're going to do the obvious. Enable IPv6 unicast routing. And also, if I'm not mistaken, I think the loopbacks are not addressed yet, so we'll pop the address on there. :1/128. Cool. So with that particular type of addressing, it kind of rules out using auto 6-to-4 tunnels, and we're not allowed to use static routes anyway. So that leaves us with one option, which is one of my personal favorites, ISOTAP. We're going to source from our loopback 0 addresses, which should be 10.yyyy, y being the router number. IPv6 addresses, we'll go 2002, CC1E, why not? :/64, and then we'll use EUI64 to finish the rest of the address, which will actually take the final 64 bits and the final 32 bits of the IPv6 address will be the hexadecimal version of our IPv4 source embedded, and that's how our tunnels are dynamic. And you'll see how that works here in a second. So go ahead and drop that on R1, R2, and R3. And you'll see this 5 EFE for ISOTAP, and then these 32 bits right here indicate our hexadecimal embedded IPv4 address. So A01, if you convert it into a decimal, would be 10.1, 101, 1.1. So if we do a look at our loopback 0 address, well, I don't have to do a show run. You can see that it's 10.1.1. And likewise, you'd see that R1, R2, R2 and R3 both have that embedded loopback. So we should be able to already ping CC1E, : 5 EFE, A02, for 10.2.2.2. Likewise for 3, if you type it right. There we go. So that gives us tunnel interfaces to work with. We're going to use EIGRP version 6 to make this dynamic where we can reach all the loopback addresses. We'll no shut the process. We'll go to tunnel 0, IPv6 EIGRP 1, INTLO 0, IPv6 EIGRP 1. Oh, also, ISOTAP does not forward. ISOTAP is a non-broadcast multi-access, and for IPv6 to work, EIGRP version 6 rather to work, you do have to use a neighbor command, which will be the same ISOTAP address for the last 48 bits with 5 EFE, and then our 32-bit hexadecimal converted address. So it'll be 202 out tunnel 0. Yes, you do have to use link local if you try and use the regular IP version 6 address. It will not work. Some iOS will warn you and tell you that it won't work. I've actually also seen some that accept the command, but you'll never see a neighbor come up. 2 came up. We'll just hang on for a second for, oh, I see what I did wrong. Go into configure mode for that, and we'll pull out that IPv6 EIGRP. Make sure we have both of our neighbors. We do. All right, our loopbacks are in there. 2002::1. We'll source from our loopback 0. That works. That works, and then we'll just verify that 1 and 2 have communication. All right, and surprisingly, that's it. So ICTAP is actually my preferred tunneling method. With auto 6-4 tunnels, dynamic routing becomes kind of a pain. You could run BGP and peer or with the tunnel addresses, but see, ICTAP actually embeds your 32-bit IPv4 address at the end of your IPv6 address. So all your tunnels can be on the same subnet. Whereas, as you'll see probably in a future post, when you do 6-4 tunneling, the first 16 bits of the address usually are 2002, but you can actually use any IPv6 address space that you want. So the first 16 bits are generally 2002. Then immediately after that, the next 32 bits are your embedded address. So you end up with your tunnel interfaces always being on different subnets, and you'll see in future video how you can still have routing with that, and you can still have full reachability with subnets with the single static route of 2002/16 going out your tunnel, but it's not nearly as clean and as efficient as ICTAP in my opinion. So that's my 2 cents. Hope this was informative.